Hey everyone, welcome to Math 104 Intermediate Algebra. So this is a challenging course requiring all sorts of prerequisite skills. So I recommend taking a look at Chapter R and reviewing everything in that chapter to make sure you're ready to go. In this video, we're going to look at some prerequisite skills. I've got a list here. We're not going to cover everything in this list. Make sure you can write fractions in lowest terms. And you can use a calculator to do that, but make sure you can do it by hand as well, because we're going to be working with algebraic fractions later on in the course. Convert between decimals, percents, fractions, and mixed fractions. We won't be using mixed fractions much in the course. If you ever see a mixed fraction, we're just going to convert them immediately to improper fractions. Add, subtract, multiply, and divide fractions and real numbers and find reciprocals of fractions. And evaluate expressions using absolute value, and that's where we're going to start in this video. Absolute value is the distance from 0 on the number line. And since distances are always positive, absolute values are always positive. So the absolute value of 2, that's 2 units away from 0 on the number line, so 2 has an absolute value of 2. Now if we go the other direction, negative 3 is 1, 2, 3 away from 0, so the absolute value of negative 3 is positive 3. So the absolute value function converts every number to a positive value. So here's an example. Now keep in mind the absolute value bars are grouping symbols, so we're going to start there. Always start inside the absolute value bar. So absolute value of negative 5, we're going to turn this positive, that becomes 5. This stays subtraction. Now we're going to work inside these absolute value bars and turn negative 2 into positive 2. So we get 5 minus 2, subtract to get 3. And that brings us to your turn number 1. Now, when looking at videos like this, or if you're in class, it's an essential part of the learning process to do the your turns. Lots of benefits to doing the your turns. First of all the homework problems and the exam problems are going to be very similar to what you see in these packets. So it's good practice for those. You can identify any misunderstandings and find any problems right away so that you can address them in class or while you're watching the video. That way when you get to doing the homework, you've got everything worked out and you're ready to go. It's going to take a lot longer to get these questions answered once you leave the classroom, you're at home working. So make sure you're going through these, identifying any problem areas, and asking questions in class right away. So your turn number 1. Now in the video, I'm not going to stop. You should pause the video and then work on your turns and then restart the video when you're done. So with this one, you got absolute value of 7. That does not turn into negative 7. Remember, the absolute value doesn't switch signs. The absolute value converts everything to positive. If it's positive, it stays positive. If it's negative, it's going to turn positive. So we bring down the plus sign, and then absolute value of negative 3 is positive 3. Add those two together, and we get 10 for that one. Now for this example, we have an operation inside the absolute value bars. We're going to do that first. So negative stays on the outside, absolute value bar, negative 5 minus 4 is negative 9. So we get the absolute value of negative 9. Now we can evaluate what's inside those absolute value bars. So it's going to turn this thing positive. So the negative, this negative stays on the outside. This turns positive, so we get negative 9. Just keep in mind that those negatives do not cancel. The reason is that negative is going away because the absolute value bar is leaving us with just one negative, which stays in the answer. Your turn number 2. I'm going to operate inside the absolute value bars first. 7 minus 3 is 4. So we get the negative absolute value of 4. Absolute value of 4 is positive 4. The negative stays. Nothing to cancel with there. So negative 4 is the answer to your turn number 2. All right, next skill we're going to look at is ordering numbers on the number line. And that's going to allow us to use the greater than or less than symbols. All right, quick review here. Less than. Greater than. Keep in mind that the larger part of the symbol always points at the larger number. All right, this is the big part. Here's the little pointing. Big part points at the larger number. So you have a larger number here, smaller number here. So how do you know if a number is bigger or smaller? Well, you look at the number line. Smaller numbers are to the left, larger numbers are to the right. So that's fairly obvious when we're talking about positive numbers or 0, but it gets a little confusing when we're talking about negative numbers. As it turns out, the number to the left is smaller than the number to the right, so negative 5 is less than negative 3, even though 5 is bigger than 3. Since we're talking about negatives, we're going to switch it. So we're going to determine whether the following statement is true or false. We had negative 5 greater than negative 3. Is this true or false? As we just saw, negative 5 is to the left, so negative 5 is smaller than negative 3. So that is false. The correct statement would be negative 5 less than negative 3. Your turn number 3. Determine whether the following statement is true or false. Negative 12 less than negative 8. Now if we continue this number line to the left, we're going to counter negative 8 and negative 12. Negative 8 will be right around here, negative 12 will be somewhere over here. Negative 12 is to the left, so negative 12 is indeed less than negative 8. So that one is true. All right, now we're going to rewrite a statement using the opposite symbol. So for the next example, we got negative 2 is less than 8. All right, now we're going to rewrite this using the other symbol. So we're going to flip that symbol around, and that means we have to flip the numbers as well. 8 is always going to be on the bigger side of the symbol, so 8 goes to the left over here, and negative 2 to the right. Your turn number 4. We're going to write negative 9 is greater than negative 17 using the less than symbol. So we're going to flip this whole thing around, negative 17 less than negative 9. All right, next up, we're going to do some exponential expressions. Now, exponents are going to be a very important part of the course. We're going to be looking at exponents and the properties of exponents in quite a bit of detail in chapter 4. So make sure you've got the idea of exponents down. Now, exponents are repeated multiplication. So, for example, we can apply them to fractions. And we got 4/5 to the third power. So, since exponents are repeated multiplication, this ends up being 4/5 times 4/5 times 4/5. So now when we're multiplying fractions, we're going to multiply straight across in the numerator, straight across in the denominator. So this ends up being 4 times 4 times 4, which is 4 to the third power. And the bottom is 5 to the third power. So a shortcut, and this is what we'll see in chapter 4, is that we can just apply this to the numerator and the denominator separately. All right, then we can evaluate 4 to the third is 64, and 5 to the third is 125. So that simplifies to 64 1/25. Your turn number 5. 5/9 squared. All right, we're going to apply this exponent to the top and bottom separately. That's 5 squared over 9 squared, so that is 25 49ths. Now we have to be real careful when applying exponents to negative numbers. So this symbol, this collection of symbols here, -3 in parentheses to the 4th power. In this case, -3 is the base. The negative is included with the base. So we're multiplying -3 times -3 times -3 times -3. And then right below we have -3 to the 5th power. So we have 5 -3s. Now when we multiply this out, negatives cancel when they come in pairs. So those cancel and those cancel. All the negatives cancel, so we're left with a positive number. So we just get 3 times 3 times 3 times 3, or 81. Now on the bottom, we can do the same thing, start canceling out negatives. Those pair cancels, that pair cancels. We're left with one negative sign. So that's going to be in the answer. There's nothing to cancel that with. So this answer is going to be negative 3 times 3 times 3 times 3 times 3 is 243. So the answer to that one is negative 243. So if you have a negative number to an even exponent, your answer is going to be positive. If you have a negative number to an odd exponent, it's going to be negative. Your turn, number 6. Expand and evaluate -6 to the 4th and -6 to the 4th. Oh, hang on, I skipped one thing there. I'll show you this other form here, -2 to the 4th power. Okay, this is very different from this one because the number is not in parentheses. Here the base is -3. The negative is included in the base. Here, the base is only the number next to the exponent, so the base is 2. That negative is just like a -1 out front that we're going to multiply by at the end. So this is the same as -2 times 2 times 2 times 2, or -16. Compare that with -2 to the 4th. All right, here, -2 is the base, so that's -2 times -2 times -2 times -2. This pair of negatives cancels, this pair of negatives cancels, we got +16. So, very different answer there if we enclose the -2 in parentheses or if we don't. All right, so make sure you know the difference between those two situations. All right, now we're at your turn, number 6. All right, so -6 to the 4th power, you got -6 times -6 times -6 times -6. Negatives cancel in both of these pairs. All the negatives are gone. Positive 1296 for the answer for that one. For this one, we just have one negative, so that's not going to cancel with anything because 6 is the base here. So you have -1 times 6 times 6 times 6 times 6. That gives us a negative 1296. All right, now we're going to review order of operations. So, step 1, within grouping symbols, we're going to apply the order of operations. So if you see any grouping symbols, we'll go on to step 2 inside that grouping symbol. All right, step 2, exponents, then multiplication and division left to right, and then addition and subtraction left to right. The thing you may have learned in high school, PEMDAS, it's close, but it's not quite accurate because PEMDAS implies that you do parentheses, exponents, multiplication, and then division. But that's not accurate. It should be multiplication, division on the same level, working left to right. And we'll see examples of why it's different from PEMDAS. We'll see that throughout this course. So first example, all right, so here's our first example. We have no parentheses, no exponents, so we're going to go right to multiplication, division, working left to right. So left to right, we got 12 divided by 6, that gives us 2. Now notice if you're doing PEMDAS, you'd go to multiplication first. So we get a 12 here. 12 divided by 12. We're going to get a totally different answer that way. So make sure you're following this procedure. Okay, now we got 2 times 2 here is 4. Do multiplication. We're going to leave addition, subtraction to the end. Always leave addition, subtraction to the end. Unless you're within parentheses. Okay, so we get 11 for that one. Your turn, number 7. (22) divided by 2 times 3 plus 4. All right, no parentheses or exponents. We're going to write right on to multiplication division. Working left to right, we got the leftmost operation here. 22 divided by 2, that is 11. Times 3 plus 4. All right, now we're going to continue on with multiplication division. We got a multiplication here, that's 33. Plus 4, add those together, and you get 37. And now we're going to see an example with a grouping symbol. All right, so we don't have any exponents. We have a grouping symbol here, though. Keep in mind that absolute value bars are a grouping symbol, so we have to work inside those first. So do 2 minus 4 is negative 2. Everything else stays the same. Make sure not to do any operations other than one we're working on. Okay, now we got absolute value of negative 2, and that's going to turn this negative positive. Keep in mind that when you have a number outside of a grouping symbol, there's no operation written there. It's assumed to be multiplication. So what we have next is 16 divided by 4 plus 3 times 2. Now we can go on to the multiplication division step. Working left to right, we're going to do this one first. 16 divided by 4 is 4 plus 3 times 2. 3 times 2 is 6. So we get 4 plus 6. And final answer of 10. Your turn, number 8. So start within the grouping symbol. 18 plus negative 30. It's like subtracting, so 18 minus 30, that's negative 12. So absolute value of negative 12. Divided by 2. Everything else stays exactly the same. Okay, now we'll complete the absolute value. Turn that into positive 12. Now multiplication division, working left to right. 12 divided by 2 is 6. We got 6 minus 6 times negative 1. This looks like it might be 0, but we have to be really careful here. Now we're going to do this multiplication. Remember, the 6 has nothing to do with it, and the subtraction sign has nothing to do with it. So make sure you write those down, keep both of those. Now we're going to do 6 times negative 1, and that is negative 6. So what we get here is 6 minus negative 6. Now subtracting a negative, that's like adding. So this turns into 6 plus 6. So we don't get 0, we actually get 12 for that one. So when you see this type of situation here, make sure you're real careful about this. Keep that negative. Realize that we're going to get a negative number here. That's like adding. All right, now we're going to evaluate expressions for given values of variables. So a little bit more order of operation practice here. The only difference is we're going to be given an expression with all variables and plug in the numbers. So we got 3d minus b over b minus 2c. Now when plugging in numbers, especially with negatives, I recommend putting them in parentheses. So we're given that a is 2, no a's, b is 3. We have 3 times, and d is negative 4, so negative 4 goes in here, minus b is positive 3. And then on the bottom, we got 3 minus 2 times, and c is going to be negative 1. All right, so there's our expression with all the values plugged in. Right now, we have a fraction to work with. We can work on the numerator and the denominator separately. We're going to apply order of operations to the numerator and denominator separately. And the reason is, the division bar, it acts like a grouping symbol. So that means you've got a group on top and a group on the bottom. So order of operations on top, we're going to do multiplication division here. 3 times negative 4 is negative 12. So we get negative 12 minus 3. And on the bottom, we get 3 minus 2 times negative 1 is negative 2. All right, now we can continue on. Up top, we get negative 15. On the bottom, 3 minus negative 2 is 3 plus 2. So that gives us negative 15 divided by 5, or negative 3. And that brings us to your turn, number 9. Evaluate the expression when a is 2, b is 3, c is negative 1, and d is negative 4. So we got negative 3d divided by ab minus 4c over 2b plus c. All right, let's plug in our values now. So we got negative 3 times d, d is negative 4. So negative 3 times negative 4 divided by, and now we do a times b, so that's 2 times 3. They're positive, I don't bother putting in parentheses there. And then we got minus 4 times c is negative 1. And we got 2 times b, so 2 times 3, plus negative 1 for c. Okay, so there's our expression with all the values plugged in. And now we can start working on, inside here. We're going to work inside the grouping symbol. And then we've got a group on top and a group on the bottom. So we'll work on these first. Negative 3 times negative 4 divided by, all right, multiplication division. So it gives us 6 minus, and since we're separated by subtraction sign, a little shortcut we can do is do this multiplication and this multiplication on the same step. Since it's separated by subtraction, they will not affect each other. So we got 6 minus negative 4 on top, and on the bottom we got 6 plus, well, I'm just going to write that as 6 minus 1. All right, next one. 3 times negative 4 divided by 6 plus 4, that gives us 10 on top. 6 minus 1 is 5 on the bottom. Okay, now we're down to all multiplication and division. So now we can just work left to right. So first one is here, negative 3 times negative 4 is positive 12. So 12 divided by 10 over 5. All right, now we have a fraction here. We can go ahead and divide this out. So that gives us 12 divided by 2. And I lost something along the way. Oh, grouping symbol. That's right. That was messing me up. That's why I was doing that first. We had a grouping symbol here. We're going to keep that grouping symbol around this the whole time. And that's why we can go from here to here, 12 divided by 2, and that gives us 6. So make sure you don't make my mistake and lose those grouping symbols. All right, next up, we got the distributive property, one of the most important and well-known properties in algebra. And we can always distribute when we see some number or expression outside of parentheses, and we have more than one term on the inside of the parentheses. Terms are those things that are separated by addition and subtraction, or an equal sign. So we can now distribute this into every term on the inside. So we have three terms. We have 2x squared, we have negative x, and we have 10. So that means we're going to do 3 multiplications. Multiplication by the first term, multiplied by the second term, multiplied by the third term. And as we'll see later on in the course, distribution is the opposite of factoring. And we're going to be doing quite a bit of factoring later on in the course. All right, so we have 3 multiplications here. We multiply a number by an expression multiplied by the coefficient. 3 times 2 is 6, and keep the variable part exactly the same. Whenever you're multiplying just a number with no variable part into a polynomial like this, keep in mind that the variable parts never change, only the coefficients change. All right, now we got 3 times negative 1, that's negative 3x. 3 times 10 is 30. So 6x squared minus 3x plus 30. Your turn, number 10. Now I'm distributing into this one. We've got 1, 2, 3, 4 terms, so we're going to do 4 multiplications. 5 times 4 is 20, so that's 20xy. Now, when you distribute a positive number in, none of the signs change. We're going to go positive, negative, positive, negative. So positive, we got negative 35x. Back to positive, 5 times 2 is 10. And then back to negative, minus 30. Generally at this level, one of the most common errors I see is sign errors. So make sure whenever you're doing multiplications like this, check your signs when you're done. We have positive, negative, positive, negative. Since you're multiplying by a positive number, nothing changes, so we should have positive, negative, positive, negative. Do a little quick check like that at the end. You'll eliminate a lot of mistakes. All right, simplifying expression. To simplify algebraic expressions, we will distribute into any parentheses in order to clear the parentheses. A simplified expression has no parentheses, so we need to get rid of those. We will combine any like terms. Like terms are those terms that have exactly the same variable part. And then we will do any leftover mathematical operations. You multiply any numbers by numbers that you can, and that will be simplified. So let's take a look at an example. We are going to simplify 3 times x plus 2y plus 2 times 4x minus 5y. All right, so we need to get rid of these parentheses. So we're going to distribute into them. Once you distribute, remove the parentheses. 3 times x is 3x. 3 times 2y is 6y. So we get 3x plus 6y there. All right, now we're going to do the second set of parentheses. 2 times 4x is 8x. And then 2 times negative 5y is negative 10y. All right, parentheses are gone. Now we can combine like terms. So let's look for matching variable parts. We got an x here and an x here. So those we can combine. 3x plus 8x is 11x. Here we got 6y minus 10y, so that's negative 4y. 11x minus 4y. So that's fully simplified. No more parentheses. None of the terms have identical variable parts, so they cannot be combined. And there's no leftover operations to do. All right, that brings us to your turn, number 11. So we'll start by distributing 4 into this set of parentheses. That gives us 8x minus 12y. And over here, now we're distributing a negative in, so it's going to change the sign here. Negative 5 times x is negative 5x. And then this sign will turn to positive. Negative 5 times negative 4 is positive 20. So plus 20y. Now we can combine like terms. 8x. Keep in mind that the sign precedes the term, so it's 8x minus 5x. So that is 3x. And then we got negative 12y plus 20y, and that is 8y. 3x plus 8y. All right, now if we want to simplify products, you might see something like this. You got 5x on the outside, 3y, and then negative 2z. So something like this. What we're going to do here is multiply all the numbers together. So 5 times 3 is 15, times negative 2 is negative 30. And then, the answer, we're going to keep all these variable parts. Can't lose anything. So we're going to keep the x, keep the y, and keep the z. Negative 30x, y, z. So multiply the numbers together and keep all the variables. Your turn, number 12. Let's multiply negative 6x times 2 times negative 5y. So multiplying all the numbers together, see, I'm going to do it a little different order here. Negative 6 times negative 5 is positive 30, times 2 is 60. My multiplication is commutative, you can do it in any order. So I usually just look for the easiest way to do it. And then we've got two variables to keep in our answer, x and y. So 60xy. All right, next up we're going to be solving linear equations. So the difference between expressions, like the ones we've worked with so far, and equations is, you guessed it, equal sign. Equations have an equal sign. So a linear equation has a variable with a highest exponent of 1. So you're not going to see any x squareds or x to the thirds or anything like that. Now the solution set for an equation is all the numbers that if we plug it into the equation, we get a true statement. All right, so solving equations, we want to get down to the form. A variable equals a constant. So something like x equals 5. There's a solution. Variable equals constant. So that's what we want our solutions to look like. At least for linear equations, because we know with linear equations there's only one solution. Now later on, we're going to be talking about sets, because we're going to be working with equations that have more than one solution. Okay, equivalent equations, it's those with the same solution set. So we're going to use these properties, addition property of equality and the multiplication property of equality. And these also work for subtraction and division. So when we apply these properties, it does not change the solution set. So as we're working through these equations, the solution we get at the end is going to be the solution that works in the original equation. And we're going to check that as well by plugging back into the original equation to make sure we got it right. Okay, solving a linear equation in one variable. First of all, we're going to simplify each side separately. Always simplify first when solving equations. That gets rid of a lot of mistakes I see. Simplify as much as possible right away. All right, next up, we're going to isolate the variable on one side of the equation. So we get all the variables to one side, all the numbers to the other. And then if that variable has a coefficient, we use the multiplication property to get rid of that coefficient. Then we should be in the form variable equals constant. Then take that answer, plug it into the original equation to make sure it's right, and we're done. So let's take a look at that procedure. We've got 4 minus 3x plus 6 equals 2x minus 5. So step one, we're going to simplify first. So this side's already simplified. We don't have any like terms over here, no parentheses. Over here we do have some like terms. We got 4 plus 6. Two constants, we can add those together to get 10. So we get 10 minus 3x equals 2x minus 5. All right, now what we want to do is get all the variables to one side and all the numbers to the other. Now let's think ahead a little bit. I've got a negative 3x over here and 2x over here. So if I add 3x to both sides, it keeps that x term positive. And then when we divide by the coefficient, we divide by a positive number instead of a negative number. So that's one less mistake to make. So I usually try to keep the x term positive. So we got 10 equals 5x minus 5. All right, now we got all the variables to the right, and we want to get all the numbers to the left. So I'm going to get rid of that 5 by adding 5 to both sides. So that's 15 equals 5x. All right, now we're down to all the numbers are on the left, all the variables are on the right. So now all I have to do is get rid of that coefficient. I'm going to divide that out, and we get x equals 3. All right, now we're down to a form of variable equals constant, so we're done, except for the check. So I'm going to take this 3 and plug it back in here. So that gives us 4 minus 3 times 3. And you can just check these with a calculator. You don't really need to write it out. It's probably faster that way. All right, now we've got plugged in, so I'm going to do 4 minus 9 plus 6 equals 6 minus 5. This is 1, this is 1, 1 equals 1. So once we plug it in and evaluate, we get 1 equals 1. That's a true statement. So that means that answer is correct. Your turn, number 13, and make sure you check your answer when you're done. All right, so we'll start by simplifying. Over here we've got some like terms, x terms, so we can simplify those. So we got negative 8x, or negative 8 minus 4x. Doing 3x minus 7x is negative 4x. Make sure you keep that negative with the 8. Don't lose the negative. Over here we get 6x plus 2. All right, now we're going to get all the variables to the right. I'm going to add 4x to both sides. Keep that x term positive if possible. Not necessary, but it's helpful. All right, so now we got negative 8 equals 10x plus 2. So I'm going to subtract 2 from each side. Negative 10 equals 10x. All right, now we have all the numbers to the left, all the variable parts to the right. So all I have to do is get rid of this coefficient now. Divide by 10, we get x equals negative 1. So let's plug it back in and see what we get. We got 3 times negative 1 minus 8 minus 7 times negative 1 equals 6 times negative 1 plus 2. So we got negative 3 here, negative 3 minus 8 plus 7 equals negative 6 plus 2. So that gives us negative 4 on this side equals negative 4 on this side. So check. And x equals negative 1 is the correct answer. All right, now let's look at an example with some parentheses. So just like before, we're going to start off by simplifying. And we simplify by getting rid of these parentheses. So I'm going to distribute in to get rid of the parentheses. So 10 plus 2x plus 2 on the left, and 4x minus 8x plus 24 on the right. Remember that negative distributing in is going to change both of those signs. So positive becomes negative, negative becomes positive. Now we can combine like terms. Got two constants over here, so that's 12 plus 2x equals 4x minus 8x is negative 4x plus 24. All right, I'm going to move all the x's to the left, so plus 4x plus 4x. And that means I'm going to get all the numbers to the right. So subtract 12, subtract 12. So 6x equals 12, divided by 6 on both sides, and x equals 2. All right, let's see what we get here when we plug in. We plug in 2 here. 2 plus 1 is 3, times 2 is 6, plus 10 is 16. So 16 on the left, and here we got 2 times 2 is 4, minus 6 is negative 2. Negative 2 times negative 4 is positive 8. 8 plus 8 is 16. So 16 on the left, 16 on the right. So that is correct. X equals 2 is the answer. Your turn, number 14. So we'll start by distributing. 3 into x minus 5, that gives us 3x minus 15. And 2 into x plus 5 gives us 2x plus 10. Now we can combine like terms. 3x minus 5x is negative 2x. And then over here we'll combine the numbers. So we get 2x plus 9. I'm going to add 2x to both sides. That's going to bring all the x's to the right. Subtract 9. And we get negative 24 equals 4x. All right, now we're down to all the numbers on the left, all the variables on the right, so we'll divide by that coefficient and get x equals negative 6. All right, let's check this. So that gives us 3 times negative 6 minus 5. Minus 5 times negative 6. Let's see what we get here. So the left side of the equation. This will be negative 33 plus 30. And we get negative 3 on the left. All right, negative 6 on the right. Negative 6 plus 5 is negative 1. Negative 1 times 2 is negative 2. Negative 2 minus 1 is negative 3. So we get the same answer. So x equals 6 is correct. All right, now to prepare for working with fractions, we're going to find the least common multiple of a set of numbers. So to find the LCM of a set of numbers, there's going to be a couple different ways we can do it. You can list out the multiples and find the first match. The least is smallest. Common, it's in all the numbers, or all the lists of factors. And it's a multiple. Sorry, all the list of multiples. So the least, it's the smallest number that's in all of the list of multiples. So we're going to find the LCM of 6, 10, and 12. All right, so we're going to list the multiples. Remember, multiples are what we get when we multiply a number by 1, 2, 3, 4, and so on. So that gives us, it's basically the same as counting by that number. So 6, 12, 18, 24, 30, 36, 42. All right, there's some multiples of 6, and we'll do multiples of 10, 10, 20, 30, 40, and so on. I think we're going to need more of these. Yeah, we're going to need some more. 48, 54, 60, 66, and so on. All right, now we got 50, 60, 70, and so on. And for 12s, we got 12, 24, 36, 48, 60, 72, and so on. All right, so there's multiples of 6, 10, and 12. So we want the smallest number that's in all of the lists. So we got 60, 60, and 60. That's the first match. So the LCM of 6, 10, and 12 is 60. Your turn, number 15. Find the LCM of 8, 10, and 16. All right, so there's the multiples of 8, 10, and 16. First match is at 80. So the LCM of 8, 10, and 16 is 80. Now later on, we're going to look at a different method of finding the LCM involving prime factorizations. All right, that is it for today. Make sure you go through Chapter R, take a look at all the topics in Chapter R, and make sure you are familiar with all those. We'll be using most of those throughout the course of this class. All right, everybody, have a great day.